Welcome student on another video lecture on topic biosynthetic pathway. In our last lecture we have seen about the shikimic acid pathway and how it will be used for manufacturing or production of primary metabolites like amino acid, and from that amino acids, essential amino acids, different secondary metabolites are produced. Now mavalonic acid pathway. The next major advance in elucidation of isoprenoid biosynthesis route was the discovery of mavalonic acid, and it is carried out in 1956. As such, mavalonic acid, that is 3,5-dihydroxy-3-methyl-valeric acid, it is a C6 acid and it is not an active and isoprene unit, because the active isoprene unit is C5 compound, carbon 5 compound, but it is a C6 compound and hence it is not active isoprene unit which forms a building block of the isoprenoid compound. So it will not form as a building block for isoprenoid compound, and for that reason too much studies or too much discoveries or experimentation is carried out, and it was established that the C5 compound for which the biochemist had been seeking so long was isopentyl pyrophosphate. So the building block or basic building block for formation of isoprenoid is isopentyl pyrophosphate, and that is obtained or derived from mavalonic acid pyrophosphate by decarboxylation or dehydration. So mavalonic acid as such, it is not a active isoprene unit and it will not helpful to produce isoprenoids by biosynthetic pathway, but the compound, that is mavalonic acid pyrophosphate, from that the isopentyl pyrophosphate is derived by decarboxylation or dehydration, and that compound is used as a building block. So the pathway produces two 5-carbon building blocks called isopentyl pyrophosphate IPP and dimethyl pyrophosphate DMAPP, which is used to make isoprenoids. Now the isoprenoid synthesis is proceeded by condensation of isopentyl pyrophosphate with isomeric dimethyl allyl pyrophosphate to yield geranyl pyrophosphate. So from these two compounds, that is isopentenyl pyrophosphate and dimethyl allyl pyrophosphate, compound is yielded, that is known as geranyl pyrophosphate. And from geranyl and farnesyl pyrophosphate, various type of structures can be built up. And when we see the stereochemically the mavalonic acid, then only R form of mavalonic acid that will give rise to terpenoids, and S form is appearing to be metabolically inactive. So the S form of mavalonic acid is inactive, only R form of mavalonic acid gives the terpenoids. So mavalonate pathway begins with acetyl coenzyme A and ends with production of isopentenyl pyrophosphate and dimethyl allyl pyrophosphate. These are the basic biosynthetic steps of isoprenoids. Terpenoids and steroids are biosynthesized by acetate. After that, the terpenoids and steroids, these are the secondary metabolites which are biosynthesized by acetate. It is best known as the target of statins, class of cholesterol lowering drug. So it comes under the class of cholesterol lowering drugs. Statins inhibit HMG hydroxymethylglutaryl coenzyme reductase within the mavalonate pathway. So this enzyme, that is hydroxymethylglutaryl coenzyme reductase, is inhibited by these drugs, and which are used as a cholesterol lowering drugs, and within mavalonate pathway they will inhibit this enzyme. So now the acetyl coenzyme A, two molecules of acetyl coenzyme A that will produce acetyl coenzyme A and hydroxymethyl glutarate synthetase, it will form 3-methyl glutarate coenzyme A, and here the acetyl coenzyme A is converted into 3-methyl glutarate coenzyme A, and which is catalyzed by enzyme hydroxymethyl glutarate synthetase. After that, 3-hydroxymethyl glutarate coenzyme A that will form a mavalonate. The mavalonate will form, and from that mavalonate it will form a mavalonate 5-phosphate. 5-phosphomavalonate or mavalonate 5-phosphate is formed. From that mavalonate 5-phosphate, it will form mavalonate diphosphate or pyrophosphate. Mavalonate is produced, and from that 5-pyrophosphate or mavalonate 5-diphosphate, it will produce a isopentenyl diphosphate. So this isopentenyl diphosphate is a basic building block which is used for synthesis of various secondary metabolites, and that is produced from mavalonic acid. So these are the basic steps of or primary steps of synthesis of isopentenyl diphosphate, or primary step in synthesis of isoprenoids. Here acetyl coenzyme A, two molecules of acetyl coenzyme A that will form a acetyl coenzyme A, and from that it will produce 3-methyl glutarate coenzyme A, and the enzyme which is used is hydroxymethyl glutarate coenzyme A. Here synthetase and here reductase enzyme is used, and which is a statin inhibitor, and it will produce a mavalonic acid. So here the mavalonic acid is produced. Now in presence of enzyme mavalonate kinase, the mavalonic acid is converted into mavalonate 5-phosphate. From that mavalonate 5-phosphate, in presence of enzyme phosphomavalonate kinase, which catalyze the conversion of mavalonate 5-phosphate to mavalonate 5-pyrophosphate. Now here from mavalonate 5-phosphate, mavalonate 5-pyrophosphate is produced, and which is catalyzed by enzyme phosphomavalonate kinase. Now that mavalonate pyrophosphate, it will converted into isopentenyl 5-pyrophosphate. Here isopentenyl 5-pyrophosphate is produced, and which is converted into dimethyl allyl pyrophosphate, and that in conversion is reverse conversion. It will converted into this and it will converted into this. So isopentenyl 5-pyrophosphate and dimethyl allyl pyrophosphates, these two compounds are produced, and from that it will produce a farnesyl. In presence of enzyme farnesyl diphosphate synthetase, it will produce geranyl pyrophosphate. Geranyl pyrophosphate is produced, and from that geranyl pyrophosphate, in presence of enzyme which catalyze the conversion of geranyl pyrophosphate to farnesyl pyrophosphate, farnesyl diphosphate synthetase is the enzyme which is used for its conversion into farnesyl pyrophosphate. So from geranyl pyrophosphate it will produce farnesyl pyrophosphate, and from farnesyl pyrophosphate, now here the different types of terpenes are produced. Squalene, from squalene or sesquiterpene, it will produce a cholesterol and biguanones and heme A sterols. geranyl pyrophosphate, phenylated proteins, all these are produced from farnesyl pyrophosphate. So this farnesyl pyrophosphate, it produces terpenes, steroids, all these are produced from farnesyl pyrophosphate. Carotenoids are also gibberellins, carotenoids, they are also produced from farnesyl pyrophosphate. So starting point is acetyl coenzyme A, two molecules of acetyl coenzyme A, they will react in presence of enzyme acetoacetyl coenzyme transferase and it will produce acetoacetyl coenzyme A. After that, hydroxymethyl glutaryl coenzyme synthesis enzyme, in presence of that enzyme it will convert into 3-hydroxymethyl glutaryl coenzyme A, and in presence of enzyme hydroxymethyl glutaryl coenzyme A reductase, it will produce a mavalonic acid. Now that mavalonic acid which is produced, it is a 6-carbon compound and which is not used as a building block, hence it should be converted into isopentenyl 5-pyrophosphate, which is a 5-carbon compound and which used as a building block for formation of isoprenoids. So that mavalonic acid is converted into isopentenyl 5-pyrophosphate under different enzymes and different steps. After that, from that isopentenyl pyrophosphate, it will form dimethylallyl pyrophosphate and geranyl pyrophosphate. That geranyl pyrophosphate is converted into farnesyl pyrophosphate, and from that different sesquiterpenes, steroids, terpenoids, all these are produced. So steroids, terpenoids, and gibberellins, carotenoids, all these are the secondary metabolites which are produced from farnesyl pyrophosphate, and this one is the mavalonate pathway for formation of isoprenoids. So the role of mavalonic acid pathway is biosynthesis of farnesyl pyrophosphate. So farnesyl pyrophosphate is produced, and from that different secondary metabolites can be synthesized. Biosynthesis of solarane can be biosynthesized by this pathway. Biosynthesis of rubber, diterpenoids are also produced from this farnesyl pyrophosphate. Geranyl pyrophosphate is produced from farnesyl by mavalonic acid pathway. Biosynthesis of cholesterol, it is one of the important molecule that cholesterol is biosynthesized by this pathway. And biosynthesis of gibberellins, these are the growth hormones which are synthesized by this mavalonic acid pathway. So this is about the mavalonic acid pathway. If you like my video, please press the like button and subscribe my channel. Thank you.